Okie dokie. Hi everyone, my name is Madison Temple and I will be telling you about the Arapaima gigas. Arapaima gigas, living fossil, river monster, or just a really big fish. For the next few minutes, I will be covering this species taxonomy, morphology, physiology, ecology, conservation status, and human interest. Hopefully afterwards, you will have formed your own opinion on what you would like to call it. Taxonomy. Arapaima gigas, locally known as the Pirarucu, was first described by Swiss physician and naturalist Heinrich Rudolf Schinz in 1822. This species classification is as follows: domain, Eukarya; kingdom, Animalia; phylum, Chordata; class, Actinopterygii, which are the ray fin fishes; infraclass, Neopterygii; infraclass, Teleosteae, which are the complete bonefish; order, Osteoglossiformes, which are the bony tongues; family, Arapaimidae, which also is bony tongues; genus, Arapaima, which is the large Amazonian freshwater fish; and species, A. gigas. Disagreements about Arapaima gigas' taxonomy is limited to the Arapaima gigas being regarded as the only species in the genus until subsequent species are discovered. This may seem confusing, but the Arapaima gigas is regarded as monotypic, although a holotypic of another fish called Arapaima agassiae existed but was destroyed in World War II. No other specimen has ever been found, so Arapaima agassiae is not officially noted as a separate species. Lack of specimens and loss of specimen types present some small irregularity in the classification and populations of the genus. Order Osteoglossiformes is comprised of 6 families and 220 species. Within the family, there are 2 genera and 5 species. On to morphology. Arapaima gigas can be identified by the species' large size. Arapaima gigas commonly grows to 200 centimeters at maturity and has reached 450 centimeters and 200 kilograms. Arapaima gigas also differentiated from other large Amazonian fish by the gray-green color fusiform body type with red flecked scales near the posterior end. Arapaima gigas possess a soft-rayed dorsal fin, posterior positioned and continuous with the caudal fin. The soft-rayed anal fin origin is posterior to the anus and continuous with the caudal fin. The hemiancircled caudal fin is rounded and relatively small compared to the total body size. Pectoral fins are short and narrow, paired and located just posterior to the opercle. Pelvic fins are abdominal. The mouth is supraterminal, with the lower jaw protruding beyond the upper jaw, which is consistent with surface-feeding fish. The mouth is specialized with a large gape. When the fish aspirates at the surface, this comes in very handy. Arapaima gigas has 21 to 37 dentiary teeth and 21 to 38 maxillary teeth. The lateral line is pronounced and terminally spaced between the dorsal and ventral sides. This fish has ganoid scales, and they are large and flake off as they're replaced. The scales of Arapaima gigas are used as protection, largely against piranha, and are highly specialized. The scales are composed of an external mineralized laminate composite structure, which basically just means overlaying bonded fibers, and internal lamellae layers. The outer layer is calcium rich, and the internal layer is composed of collagen fibers. The scales have layered and rotating microstructures that resist cracking and damage while giving the body flexibility for movement. On the left, you can see a live fish's scales, and on the right, you can see the scales harvested individually. On to physiology. Respiration of Arapaima gigas is notable as an obligate air breather species. There are 370 known extant species consisting of 49 families of air-breathing fish, both obligate and facultative. Air breathing evolved independently 38 to 65 times. Depending on the sediment levels of the Amazonian River, Arapaima gigas must breathe at the surface at least once every 15 minutes. Arapaima gigas studies from 1978 found the Arapaima gigas weighing between 2 and 3 kilograms utilized ventilation 16 to 24 times per minute and lung ventilation every 1 to 2 minutes. A specimen found in water with normal oxygen levels will obtain approximately 75% of oxygen intake from air breathing, which is still fairly large for normal oxygen levels. The level of oxygen from the air will increase as the hypoxic nature of the water increases until the oxygen intake reaches 95% in anoxic water. As you can see in the picture of the Amazon River, sometimes the swift change in sediment levels can increase or can affect the fish that live there greatly. Arapaima gigas use only gill respiration for the first 9 days post-hatch. The gills of the adults are greatly reduced and used largely for nitrogenous waste excretion via passive diffusion. The kidney of Arapaima gigas is enlarged and can account for up to 40% of total nitrogenous waste excretion. Arapaima gigas utilizes buccal pumping and so does not need to swim continuously. The oral valve prevents water from flowing back out of the mouth. Arapaima gigas is an osteoglossidae teleost with a modified swim bladder called a physostomus gas bladder. The pneumatic duct connects the esophagus and gut to burp and gulp air. Arapaima gigas lives in a tropical freshwater environment and so is hyperosmotic with a stenothylane osmoregulation. Arapaima gigas uses beta chloride cells and is homeothermic ectothermic. Ecology. Arapaima gigas is found exclusively in the Amazon River Basin in South America. Arapaima gigas participate in lateral migration between river channels and floodplain habitats. The Arapaima gigas is categorized as sedentary despite its migration because the migration is so short. During seasonal floodings, the Arapaima gigas migrate to higher elevation habitats of the flooded forests and then back to channels and eventually to lakes during the dry season. Arapaima gigas is often the first large aquatic organisms to inhabit the flooded forests, as air breathing allows for survival in the hypoxic water and elongated body shape allows swimming in the shallow waters. The forests also provide ample food sources. I'm gonna play this video of some captive Arapaima eating some vegetables and squid, it looks like. Anyway, the forests provide ample food sources. Arapaima gigas will also eat most organisms that fall into the water, such as birds and lizards, as well as vegetation, and have no natural predators apart from the piranha eating on weakened or the corpse of an already dead Arapaima. Newly hatched offspring will often feed on insects until the age of 1. All right. During low water levels, Arapaima gigas move to lakes, which provide protection against the El Nino droughts and are found in higher concentrations. As the water levels get lower, the fish are forced closer together, but that does provide for more mating opportunities. Arapaima gigas reproduce during the dry season for them, which is February to March, and Arapaima gigas create nests by hollowing out holes in the sand with their caudal fin that average 70 centimeters long. Thousands of eggs are laid in the nests, which hatch between October and November. Hatching during the dry season is actually beneficial to the fry, as the hypoxic water cannot facilitate many large fish, and would-be potential predators can't survive. The adult Arapaima gigas aerate the fry, which are dependent on only gill aspiration. Fry incubate for a month in and around the male's mouth. Fry are drawn to the mouth during potential danger by the male exuding pheromones from the head that attract the offspring. Arapaima gigas reach sexual maturity in 4 to 5 years and can live for up to 20 years. Conservation status. The conservation status of Arapaima gigas is listed as data deficient, as of the species' last assessment was August 1st, 1996. Despite insufficient data, Local people that fish for Arapaima gigas have noted a steep decline in the number of large individuals. The decline is thought to be a result of overfishing. Traditionally, Arapaima gigas are speared or netted when surfacing to gulp air. Predictable air breathing makes the Arapaima gigas relatively easy to catch, so much so that in 1976, a government conservation firm banned fishing for these fish from October to March because the low tide means that this species can be easily seen through the water and have no chance to escape the hunters. This group also set a length minimum of 1.5 meters for all hunted Arapaima gigas throughout the year. Arapaima gigas populations continue to decline in the wild. The efforts are being made to reintroduce farm-raised populations into the wild and replace wild-caught Arapaima gigas in fish markets. Many South American governments have attempted to encourage farms to raise Arapaima gigas by stressing the ease of rearing many fish in oxygen-scarce ponds for maximum benefit and profit. The Yucatan region of Peru declared Arapaima gigas as no longer in danger as of 2012 through the efforts of local people taking up aquaculture instead of growing coca leaves for cocaine production. Arapaima gigas are occasionally used as ornamental fish for private collections, as well as in aquariums and zoos around the world. Conservation is a concern for Arapaima gigas populations. Further fishing regulations to protect Arapaima gigas from continuing to be overexploited are needed. Deforestation and river and air pollutions are also a concern for Arapaima gigas' future. Arapaima gigas population densities were locally extinct at 19% of traditional fishing communities, as well as only well managed in roughly 5% of those fishing communities. The results of conservation efforts are difficult to discern because of high levels of poaching and data scarcity. Interest to humans. Arapaima gigas is prized as a high meat yielding fish with up to 70 kilograms of available meat that can be harvested from a single fish. The meat is prized as being boneless, odorless, and mild in flavor. The meat recently gained notoriety across the United States when farm-raised Arapaima gigas became available in Whole Foods. Additionally, the bony tongue is used as a scraping tool, and the bony scales are used as nail files by Native people. Local governments in South America stock lakes with Arapaima gigas to encourage the fish's harvesting and farming. Local people who are willing to begin aquaculture can also be given government assistance to install fish farming ponds. Farming Arapaima gigas over cattle is environmentally as well as economically beneficial. 1 hectare of cattle pasture can produce a maximum of 180 kilograms of meat, but if turned into a fish pond, can produce 9,000 kilograms of meat. Arapaima gigas can reach up to 9 kilograms in weight in farms in less than a year, with females depositing eggs multiple times a year, providing a constant supply of new fish to the farmers. Local Arapaima gigas fisheries have also begun to release adolescent fish into the wild to restore native populations. In the United States, Arapaima gigas is likely to do well in places like Florida as they survive in water around 16 degrees Celsius. Temperature-restricted survival indicates that in the event that the fish escape the fish farm into another water source where they would likely prey on other fish and wildlife, reproduction and continued survival or the spread to other places is extremely unlikely, which is great when you're considering farming fish. As you can see from this picture, many fish can survive in a very small enclosure and can be fed things as simple and easy to get as fish pellets. What I hope you take away from this presentation is as follows. They are ray-finned, complete-boned, and bony tongues, can be identified with their large size, coloring, mouth shape, and tough scales. They are air breather species. They migrate and are protective parents. They need to be studied more intensely to continue to ensure their conservation. And farming is a big business that you could get into if you want to move to Florida. This list includes a few sources that I used for my paper that I found most useful and interesting. I'd like to thank Dr. Hansen, of course, and the poor peer editors that edited my papers, and the rest of the class for making this semester bearable. This concludes my presentation. Thank you for watching.